Hello and welcome. I'm an avatar created by Yili Lin, a health services research PhD student at George Mason University. Today's topic is performing ANOVA in R. ANOVA, analysis of variance, is a statistical method used to test for significant differences between the means of three or more independent groups. Use ANOVA when you want to test hypotheses about group differences. For example, you might want to know if different teaching methods result in different student performance levels. There are two main types. One-way, ANOVA, used when comparing means across one factor. Two-way, ANOVA, used when comparing means across two factors. It can also test interactions between factors. Common assumptions for ANOVA. ANOVA assumes that the model's residuals are normally distributed, which affects the validity of the p-values in the ANOVA table. Homogeneity of variances, homoscedasticity, means group variances should be similar. Otherwise, the ANOVA F-test results may be inaccurate. Independence of observations ensures that each observation is separate, making group variations meaningful. Outliers are data points that differ significantly from others and can distort statistical test results. First step, preparing the data. Reads a file into R and stores it in the data variable. To inspect the data, use the head function to view the first few rows, str to check the structure and variable types, and summary for basic descriptive statistics. Dealing with missing values is crucial when preparing data, and various methods can be applied based on the nature of the data. Please review the session on addressing missing values in R. Check ANOVA assumptions to ensure your data is suitable. For details, refer to Testing Assumptions for ANOVA in R. Ensure your variables are in the correct format, converting them to factors if needed. Step 2. Performing ANOVA in R. The AOV function fits an ANOVA model where the dependent variable is real income and the independent variable is the state abbreviation, representing the factor being compared. The independent variable state abbreviation, independent variable 1, and unemployment, independent variable 2, are the two factors being studied. The star operator allows for the assessment of both main and interaction effects. In the two-way ANOVA output include main effects, the individual impact of each factor. Interaction effects, whether the effect of one factor depends on the level of another. Step 3. Data interpretation and validation. Review the ANOVA table to determine if the main effect, such as group differences, is statistically significant by examining the p-value. For more details, refer to the session on interpreting ANOVA output in R. Conduct post-analysis assumption tests by checking the residuals to validate the results and ensure that the underlying assumptions of the analysis are met, as outlined in the session on testing assumptions for ANOVA in R. Consider conducting additional analyses to explore your data further, such as interaction effects, covariates, etc. Reflect on the findings and identify any further research or analysis needed based on your results. Have your analysis reviewed by peers or collaborators to ensure the accuracy of your conclusions and double-check the code and results for any errors or oversights. Step 4. Communication and reporting. Create plots like box plots, bar graphs to represent differences between groups. Summarize the main findings from your ANOVA, noting whether the assumptions were met and how this impacts the interpretation. Include ANOVA tables and relevant visualizations to illustrate the results. Create a clear and concise report or presentation, summarizing the methodology, analysis, results, and conclusions. Tailor it to your audience, relate the findings to your research questions or hypotheses, and discuss the practical or theoretical implications. By following these steps, you ensure that your analysis is thorough, your results are valid, and your findings are effectively communicated.